Number 7, what is the profitability index of an investment with cash flows of years 0 through 4, and then they tell us the cash flows respectively, and a discount rate of 14%. Should the firm accept or reject the project based on its profitability index? Okay, remember we said that profitability index is equal to 1 plus the NPV divided by the initial investment. But we said this thing is positive. This thing is positive. Okay, so first thing we're going to do is figure out the NPV. I'm going to get my calculator out to do that, and I think you should too. CF, second, clear work. What do I put in for CF0? 440 negative. Enter. Got to hit enter or it doesn't work. By the way, did I hit clear? I want to clear that out. Okay, 440 negative. Enter. Arrow down. What's C0? 120. Enter. Arrow down. Arrow down. What's C02? 140. Enter. Arrow down, arrow down. What's C03? 155. Enter. Arrow down, arrow down. What's C04? 180. And I just hit enter and I'm good to go. How do I find the NPV? Yeah, I hit the NPV button and then it asks for I. What's I? 14. I hit enter and then what do I do? Arrow down, and then what do I do? Compute. I'm getting $15.82. Is that what you're getting? Only it's negative. Do you see that? Well, by the way, we already know we're going to reject this project, right?
This is negative, right?
Yeah, exactly. Now, so what we have right now is that this is minus $15.82. And how much was our initial investment? 440, but keep in mind it's positive. Positive. So let's go ahead and take this number, divide by 440 equal plus 1. So now we've got, and it's not NPV by the way, we're just doing the math there in that spot. Now we know that our profitability index was 0.96. What's the rule for accepting or rejecting projects based on profitability index? We only accept ones that are greater than 1, right? We only accept ones that are greater than 1. Now, my guess would be that whoever asked for this, what you did is you included the initial investment as a negative. And when you did that, that made this fraction here positive. And so you came up with the answer of 1.04, which would mean that you would accept the project. So you got to be careful of that.
So why did you divide by a positive 440 instead of a negative 440?
Because this is the initial investment, not the initial cash flow. How much am I investing? Okay, other questions on this one before we move on?
Divided by, it says they're negative, but we just make a positive. Right?
Yep. If I ask you, how much did you have to invest, what would your answer be? Would it be negative 440? No, it'd be 440. Good question. Other questions? Okay, let's move on to number 9 here. Compute the IRR statistic for Project X and note whether the firm should accept or reject the project with cash flows as shown if the appropriate cost of capital is 10%. So here we go. I'm going to say CF second, work. What should my CF0 be? Yeah, 100, negative, enter, arrow down. What is C01? 100, negative, enter, arrow down, arrow down. What's C02?
0.
0. Sometimes people think, oh, well, I could just skip it because it was 0. Wrong, because of the time thing, right? Arrow down, let's see 0, 3. 150. Enter, arrow down, let's see 0, 4. 100. Enter, arrow down, let's see 0, 5. 25. Enter. Now, what button should I hit next? IRR. And there it is. Yeah, it says IRR is 0, is that correct? No, what do I gotta do? Compute. And when I do, it comes out to be 11.06%. So we know it's gonna be one of those two bottom ones, accept or reject.
Reject.
Accept. Why are we accepting? Yeah. If the IRR is greater than the discount rate, then we accept. Unless we have multiple IRRs, right? What's the other place where IRR lets us down? When we have what kind of projects? I'll get you started here. Mutually exclusive. When we have mutually exclusive projects, that's the other place IRR lets us down. But they haven't mentioned anything about mutually exclusive projects here, and they haven't we don't have more than one sign change. Did you notice that? We still have negative at time 1, but there's only one sign change from negative to positive, so it's still what we consider conventional cash flows.
So it's not if it's greater than 0, it's if it's greater than the, in this case, the cost of the capital.
Yeah, greater than the appropriate discount rate.
Okay.
Okay, and now moving on to 13. We've had multiple requests for this one. First thing you want to do when you see something this long is you want to read down here. And when it says calculate the NPV of the project, what should you do? Skip it, right? It's going to take a long time. You should skip it. Come back when you finish the other questions. Of course, that's not an option for me right now, so we'll go ahead and solve this thing. A project requires an initial investment in equipment of $81,000, requires an initial investment of working capital of $19,000. You expect the project to produce sales of revenue of $100,000 per year for 3 years. You estimate manufacturing costs to be 60% of revenues. Assume all revenues and costs occur at the year end. Equipment depreciates using straight line depreciation over 3 years. At the end of the project, the firm can sell the equipment for $20,000 and recover the investment in net working capital. Corporate tax rate is 30% and the cost of capital is 15%. Oh my goodness. Okay, so let's start by figuring out, first thing I want to ask myself is how long is the life of this project? What's the answer? 3. And then I want to make some columns here. I want to have year 0. And I've got year 3, that's my last year. And then I want a column for every year in between. And in this case, it's just years 1 and 2. Why am I doing that? Because years 1 and 2 are going to be identical. If this were a 5-year project, what would that middle column represent? 1 through 4. As long as there's not something goofy happening like the net working capital fluctuating with sales or sales fluctuating, as long as nothing's fluctuating, this works. Now, what we're going to try to figure out here is OCF, and we're going to subtract the net capital spending, and we're going to subtract the net working capital. And so what I need to do is figure out those things, and when I do that, that's going to give me CFFA. What's CFFA stand for?
Cash flow promise.
Very good. Cash. Oh, what the hell?
Nice.
What's that?
Of course.
All right, don't fall asleep. Huh. Well, that really sucks. I have no idea what to do about that, but we will move on. Okay. So let's talk about, first of all, there are some easy things we can knock out here. What is going to be our operating cash flow at time 0?
0.
Yeah, it's always 0, right? What's going to be our net capital spending for years 1 and 2? Yeah, it's not going to be anything, right? And then we've got our change in net working capital for years 1 and 2. Yeah, it's going to be 0 also. Oh, thank you. Okay, so we've already got a lot of this knocked out. Now, they tell us the change in net working capital. How much do we have to invest at time 0? 19,000? And what does that mean for over here? Yeah, minus 19,000. Okay, now, net capital spending. How much are we investing at time 0? 81,000. And they tell us we could sell this thing for 20,000 here. Is that what I plug in here? Yeah, it's the after-tax salvage value. So ATSV is equal to the market value minus the tax rate times the market value minus the book value. And here they tell us the market value is how much? 20,000. Minus, what's our tax rate? 30%? Is that right? Multiplied by 20,000 minus 0. How did we know it was going to be 0?
Straight line.
Yeah, we straight line depreciated it to 0 over the life of the project. Is the book value always going to be 0 at the end? Maybe not. We don't know. So that's why we go ahead and write all this out. In the end, when I look at this, I think this is going to turn out to be 14,000 bucks. Does that sound right? Okay, if money into the project over here was positive, what does that mean for the sign of this after-tax salvage value? It's got to be negative. Oh, whew. Now we only have one thing left to calculate. We need to find our OCF. OCF is equal to EBIT plus what? Plus depreciation minus what? Taxes. This is where it's going to get hairy, and we're going to have to do some accounting. What do they tell us the expected annual sales are? 100,000. And how much do they tell us is going to be our cost? 60%. Would you believe me if I told you that that was $60,000? Some people don't get that. I get it. Okay, so there's our costs are 60,000, and now there's something else that we're going to have to subtract. What are we going to have to subtract? Yeah, depreciation. Now, what do they tell us about depreciation? They tell us that we are straight line depreciating this thing over how many years? 3 years. So here's 81,000 divided by 3. I think that's $27,000. Is that right?
Yeah.
Okay. And keep in mind, we never include interest when we're doing capital budgeting analysis, so we're not going to do it here. So if I want my EBIT, all I have to do is take 100 minus 60,000 minus 27,000. I think that's $13,000. Is that correct? Okay. Now, how much is the tax on $13,000?
30%.
3,900, right? 0.3 times 13,000, is that right? Okay, do we have enough information now to figure out our OCF?
Yes.
Yeah, we know that our EBIT is 13,000. We know that our depreciation is 27,000. And we know that our taxes are 3,900. So 40,000, I think this is 36,100, is that correct? Is that right? Very good. You guys are the ones with the calculator, right? I'm just making this stuff up as I go along. Okay, so what do we do with that number? It goes here, and where else does it go? Year 3. Okay, now I can do for these 3 columns. So OCF minus 81,000 minus 19,000 gives me minus $100,000. The second one's real easy. It's just OCF. And the third one, this is where people get screwed up. Because we're taking a minus times a minus, what do we get? Plus. And so we've got 36,100 plus 14,000 plus 19,000. I think that's $69,100. Is that correct? Okay. What do you think I'm going to do next? Yeah, I got to get out my calculator. And I'm going to say CF, second, clear work. By the way, we had 5 cash flows in there previously. If we didn't clear the calculator out, cash flows 4 and 5 would be hanging out there just waiting to beat us up, right? We don't want that. So CF0 is equal to 100,000, negative, enter, arrow down. What is C01?
36.
Yeah, 36,100. Enter. What is F01? 2, because that happens 2 years in a row. Enter, arrow down. What is C02?
69.
Yeah, 69,100. Enter. What button should I hit next? NPV. And what should I put in for I? 15. Enter. Arrow down. Compute. I would tell you to always start with the question, what's the life, right? And then, once you figure that out, then you can go ahead and set up this simple table unless they've thrown some sort of wrench in there. By the way, do you think I would throw such a wrench into a... Canada says yes. I'll tell you this, probably not for an NPV problem, but maybe for a change in net working capital, right? Something that you figure out in the middle, but I wouldn't do it on an NPV problem. Questions? Mr. Nylon, did you ever get it right? Did you clear out your cash flows before we started?
I did.
Got it now?
Yeah, I must have put in the wrong numbers.
You know, that's one of the bad things in finance. If you put in the wrong number, you get the wrong answer. Go ahead.
If, like, when using the straight line depreciation method, if there is given salvage value for the asset, do we need to subtract the salvage value when we calculate the depreciation or not?
Okay. So I will not be giving you any problem like that. But if someone was silly enough to straight line depreciate to a salvage value, you're absolutely right. So if it were 101,000 and your salvage value were 20,000, then you would only be depreciating that 81,000 over 3 years, not the full 101,000. Why do we straight line depreciate to 0? Because, and we know the asset's most likely not going to be worth 0. I would rather over depreciate because then I underpay my taxes, right? The government allows me to do it. By the way, if the government allows you to do something to reduce your taxes, is it unethical? Yeah. Should you do it? Absolutely. In fact, you have a responsibility to do it, right? Maximizing shareholder wealth. Not maximizing taxpayer wealth. Or maximizing government waste, or whatever it would be. By the way, you think the agency problem is bad in business. What do you think it's like in government? At least in business, if you own part of the shares, your own waste hurts you. What about in government? Senators, congressmen, they all get paid the same regardless of how much money they waste. So why not waste a lot? Okay, on to question 14. You are trying to pick the least expensive machine for your company. Oh my goodness, what does this sound like? What kind of a problem? Oh, you're trying to pick the least expensive machine. So you're comparing two options. This is toward the end of chapter 8, where we were looking at, I'll bet they're going to have different lives, right? Expected life of 3 years and an expected life of 4 years. So this is looking at projects of different lives. And the way we're going to do that is to look at, yeah, the effective annual cost or equivalent annual cost, EAC, right? Okay, you're trying to pick the least expensive machine for your company. You've got two choices. Machine A, which will cost $60,000 to purchase and will have an OCF of negative $3,500 for 3 years, or machine B, which will cost $70,000 to purchase and have an OCF of negative $4,900 annually. Okay, here's what blows students' minds. This negative OCF, you can think of it as a positive maintenance cost, right? That's the trick to this problem. So, we've got machine A, B, we've got time 0, time 1, time 2, time 3, and time 4. Machine A costs us how much up front? $60,000? And then how much does it cost us every year?
$2,500 for 3 years.
So $3,500 for 3 years?
Yes.
Yeah. Now notice, I'm putting these in all as positives. These are all cash flows in the same direction, because when this money, when we spent it, that was a cash flow out of our hands. This is also a cash flow out of our hands, so we just make them all the same sign. Now, what about machine B? How much does it cost? $70,000. And how much is its annual cost? $4,900. Yeah, 4 years. Okay, so we know that what we've got to do first for both of these, number one, we need to find the sum of the present values of those expenses. And we're just going to use our NPV to do that. And then the second thing that we're going to do is to find PMT, because we're going to turn these things back into an annuity with the same present value as the original machine. So here we go. CF, second, clear work. What would CF0 be for machine A? 60,000, and resist that urge to make it negative, because these are all in the same direction. Arrow down, what do I put in for
Negative,
C01?
but not negative. So.
It's not.
Okay.
Remember, these are all cash flows in the same direction. But your instincts, your finely honed instincts that I have given to you, right? They tell you to put a negative in there. But you've got to fight that, right? Because these are all cash flows in the same direction. Okay, what's C01? 3,500. Enter. What's F01? 3, because it happens 3 times in a row. What button do I hit next? NPV. And what do I put in for I? 13. Enter. Arrow down. Compute. There is the present value of all the expenses for machine A.
Yes, clear.
Oh, not quite yet. I'm going to store 1 just in case everything goes terribly wrong. And then I'm going to hit clear a couple of times.
Present value.
Yeah, but first I'm going to say second clear TVM, right? Now I'm going to put this in as a present value. What should I put in for N? 3. Why 3? That's the life of the project, right? 3, N. And then, what do I put in for I per Y? 13. And then what do I do? Compute? Payment. Very good. I'm getting an equivalent annual cost. That can't be right. No, yeah, that could be right. Is this what you guys are getting?
Yeah.
Okay. I'm getting an EAC of $28,911.32. Okay. Now, let's go ahead and we will do the other one. CF second, clear work. 70,000, positive. Enter, arrow down, C01. 4,900, enter. What is F01? 4, because we have a life, we've got 4 of those payments. Enter. Okay, NPV. 13. Enter, arrow down, compute. I'm getting $84,574.91. Is that what you're getting? Okay, so here's what I'm going to do. I'm going to store 1 in case everything goes terribly wrong. Then I'm going to hit clear. Then I'm going to say second, clear TVM. What button do I hit next? Present value. What do I put in for N? 4, because this machine has a 4-year life. What do I put in for I or Y? Yeah, 13. N. No, I for Y. There we go. Whew. Now, what do I compute? Payment. And I'm getting $28,433. And the cents really don't matter because we already know our answer. Which one of these machines would you choose? Yeah, B. Why?
Less cost.
Yeah, it costs less, right? The equivalent annual cost is lower. You always want the lower equivalent annual cost. And if you can't remember that, just trust your greedy little heart. If I see 2 things that will do the same thing for me and one of them costs less, which one do I buy? The cheaper one. Okay, any other questions on this question? You are considering the purchase of 2 machines required in your production process. Okay, so these are it's basically the same kind of question, only this time they actually ask you for the numbers. So, let's see, what are the years on these things? 3 years and 2 years. So here's what we're going to do. How much does the first machine cost? 45?
45.
And then what's the annual maintenance?
65.
65. And it lasts how many years?
2.
2. The second machine costs how much? 80? 35? 35? 35. Fiat? Honda. You guys know about Fiat? Well, Italian car doesn't cost a lot, but your maintenance is going to be high and it's going to die in a short amount of time. Honda costs more, but your annual maintenance is lower and it lasts you longer. Okay, now, we still don't know which is better until we do the math. So here we go. CF, second, clear work. What do I do for machine A, for CF0? 45, enter, arrow down. What about C01? 65. Enter, arrow down. What do I do for F01? It's 2. Enter. What do I do next? NPV, very good. And what do I put in for I? 13. Now it just happens to be the same number as the last one. They don't have to be. Arrow down, compute. I'm getting $153.43. Is that what you're getting?
Yes.
Okay, so here's what I'm going to do. Store 1, very good. I'm going to hit clear twice. And I'm going to say second, future value to clear the time value of money keys. Then what do I do? PV. What do I put in for N? 2, because it's a 2-year life machine. And what do I put in for I over Y? 13. I over Y. Now, what do I compute? Yeah, compute the payment. And I'm seeing that the equivalent annual cost is $91.98. Is that what you get? Okay. Now, let's do the other one. CF, second. Clear work. What else should I put in for CF0 for machine B? 80. Very good. Enter. Arrow down. What about C01? 35. Enter. Arrow down. What about F01? 3. Enter. What button should I hit next? NPV. And what should I put in for I? 13. Enter. Arrow down. Compute. What do I do next? Store 1, just in case everything goes horribly wrong. Hit clear twice. Second, future value to clear the time value of money keys. What do I do next? PV, present value. What do I put in for N? 3, because this thing has a 3-year life. And what do I put in for I per Y? 13. And what do I compute? Payment. I'm getting $68.88. Which machine would you choose? And why? Yeah, because $68.88 is less than $91.98. Does that make sense? Okay. Oh my goodness, we're in the, wait a minute. Have I skipped one? No, I just forgot to cross it off. You are considered, oh no, wait, that's the last one we did. Here we go. The following data for a merger is given. We've got firm A, we've got firm B, and then we've got firm AB. One thing you need to be careful about here, read that last line. The total value of firm AB represents the total value in a stock acquisition where all the value remains in the firm. In other words, this value AB that we're given is the standalone value of A plus the standalone value of B plus the incremental value. All the value stays in the firm. Okay. They're telling us that firm A has proposed to acquire firm B at a price of $20 per share. Calculate the NPV of the merger. Whew. Okay. Now, let's walk through how we're going to get there. We need to figure out VB star, which is the standalone value of B. B is a target, isn't it? Yeah. Plus what? Yeah, the incremental value. And then we're going to say that the NPV is equal to VB star minus the cost to A to acquire B. Okay, so we need to start doing some math here. Do we know this?
Yes.
Yeah, they give this to us. Can we calculate this and this? Yeah, and so that's how we're going to figure delta V. So let's go ahead and put those numbers in here. This is 11,200. How do I get the value of A? Standalone.
Price per share times the shares.
Yeah, price per share times the shares, which I think is 100 times 100. Is that right? Plus, what's the standalone value of B? Is it 10 times 40?
Yes.
And then that's plus the delta V. Now let's go ahead and do our math out here. 100 times 100, I think that is 10,000. Does that sound right to you? And I think this one is 400. Is that right? If I take 11,200 minus 10,000, that's 1,200, minus 400, I think delta V is 800 bucks. Is that right? Yeah, so delta V is equal to 800 bucks. You can check my work later, or I guess we'll find out here in a minute. Okay, now VB star is equal to VB plus delta V. We said the standalone value of V was 400, and delta V was how much?
800.
800. And so VB star is 1200. So now we can figure out NPV, because we know VB star is 1200. And now we need to figure out the cost to A to acquire B. How much are they paying for every share of firm B's stock?
$20.
20. And how many shares are outstanding? 40. And so it's going to be minus 20 times 40, which I believe is 800. Is that right? And so the NPV is going to be 400. Does that make sense? Now, how many steps did we have to go through? Quite a few, right? And I could have gone one further and said, what's the new share price? And you could have all sorts of fun with this. We're not going to do that. If it comes up in another question, we'll do it then. Now we are on to number 18. The cost of capital of firm A is 12.2% compared to 17.1% for firm B. Oh, by the way, where should you always start on these? Start at the end, right? Which of these rates is the most appropriate to use as a discount rate when analyzing the acquisition of firm B by firm A? Do you guys remember a story I told you about buying a Scottish oil field firm when I worked at Halliburton? And they were incredibly risky. And so their assets were incredibly risky. And when we went to buy those people, instead of using our discount rate, whose discount rate should we have used? Theirs, right? We should have used their cost of capital. So basically, all we're looking for here is the target firm's cost of capital. And as we read these numbers, we're going to ask ourselves the question, is that the target firm's cost of capital? The cost of capital at firm A is 12.2%. Is that the target's cost of capital? No, that's the bidder's cost of capital. Compared to 17.1% for firm B. Whew. Is that the cost of capital for the target? Yeah. Is that the correct answer? Yeah. Do I need to read any further? No. Now, students hate this. They say, why do you give me more information than I need? And my response to you is, in the real world, the situation is actually worse because you have less information than you need. And so what does that mean you end up doing? If I can avoid this, I would love to, right? Moving on to 23, you are considering purchasing a put option on a stock with a current price of 32. The exercise price is 35, and the price of the corresponding call option is $2.25. According to put call parity, if the risk-free rate of interest is 4% and there are 90 days till expiration, the value of the put should be, oh my goodness. Let's write a formula up here on the board. And you tell me if I get the formula right by looking at your chapter 17 slides under put call parity. Here we go. I think it is P sub 0 plus S sub 0 equals C sub 0 plus E divided by 1 plus R to the T. Is that correct?
Yes.
Okay. Now, what are they asking us to calculate? They're asking us to calculate put. So I need to rearrange this by subtracting S sub 0 from both sides. P sub 0 is equal to C sub 0 plus E divided by 1 plus R to the T minus S sub 0. Are you with me so far? Okay, now they're telling us that the call option is $2.25. That's the premium. And what is the exercise price? 35. 35 divide by, what's the risk-free rate? 4%. 1.04. And they're telling us it's 90 days. What portion of a year is 90 days? Well,
25%.
you know, it depends on whoever wrote the question. Thankfully, it's multiple choice, right? Because you'll find some a-holes in finance who will say there are 360 days in a year. And why do they do that? Because it makes the math easier. Back when we used a quill, that made sense. What about now? The calculator doesn't care, right? Okay, so I'm going to go ahead and put it in there as 365. And if you really wanted to be nasty, you could say 0.25 because the average, yeah, anyway. Okay, then minus, what's the stock price? 32. Okay, so here's the way I'm going to approach this. Where is the most difficult math in all of this? Right there, isn't it? Okay, so I'm going to start down. In fact, I'm going to start on the bottom. And I'm going to say 1.04. Y to the x. You guys see y to the x? It's above the 9.
Yeah.
Then I'm going to open parentheses. 90 divide by 365. Close parentheses, equal. So there is my bottom piece. And it kind of makes sense because that's close to being 1% for a quarter. Does that make sense? Okay, now keep in mind though that that number's on the bottom. There are two ways we can go about this. We could either store this number, then type in 35 and divide by recall, which is what most of you are going to do. Or we could just hit the 1 over the x button and multiply by 35. Do you see if I hit the 1 over the x button, it just throws that down to the bottom? And so here's what I'm going to do. I'm going to hit the 1 over the x button, which I think is this one here. Yeah. And then I'm going to multiply by 35. And so when I do this, I'm getting $34.66 roughly for this thing right here. I'm going to subtract 32. And I'm going to add $2.25. And that's going to give me $4.91. So when you start seeing that where they're asking you for the value of a put option and giving you the value of a call, or they're asking for the value of a call and giving you the value of a put, you start with this formula, you solve for the thing you want, and then you plug and roll. Now, could we have done this a different way? Yeah, we could have said C sub 0 is equal to plus E divided by E to the R P minus S sub 0. And the answer would have come out so close that you would have still gotten the same multiple choice answer. Questions? Okay. Let's see if we have time for one more. A call option has an exercise price of 34 and a stock price of $36.50. If the option is trading at $2.75, what is the time or speculative value embedded in the option? Okay, remember that the option premium consists of two things. Number one, the intrinsic value of the option. And number two is that speculative value. So what we've got to do is figure out what is that intrinsic value, subtract it from the premium, and that will give us our speculative or time value of the option. So, what is the intrinsic value here? Well, this is a call option. And so it's always going to be stock price minus the exercise price, or zero, whichever is greater. What's the stock price here? $36.50, and the exercise price is $34. $36.50 minus 34 is positive $2.50. Which is greater, positive $2.50 or zero? Positive $2.50. So there we go. That's the intrinsic value. But this thing is actually selling for $2.75. $2.75 minus $2.50 leaves me with 25 cents. So 25 cents is the speculative or time value embedded in the option. And I actually had a guy on YouTube that watched my last lecture, and he said two things. He thinks it's pronounced expiry, which I looked it up. It actually can go either way. And the other thing he said was, where I'm from, we don't call it speculative value or time value, we call it the extrinsic value. And so the value of the call or the put is equal to the extrinsic value plus the intrinsic. However, it helps you to remember that's the way you should go with it. Questions? Okay, now I want to remind you guys what's at stake for the top scoring person in the class. The golden thinker is still on his throne and awaiting you if you are the highest scorer in the class. So for next time, what do you need to do? You need to look at the remainder of that practice and see if there are any other problems that you want to see before the exam. Questions? Okay, I'll see you next time. Remember to like and subscribe and share.